Hello children, you're welcome to this segment of the program. It is mathematics time, and that means it is time to have some fun. Today promises to be interesting. I am Uncle Agbaje. In mathematics today, we'll continue our work on plane shapes, but we will be looking at something entirely different, and that is circle, specifically parts of a circle. Now you might wonder, does a circle have any parts? Well, we'll see about that today. Let's begin with correction to our last homework. You were asked to draw a trapezium and state 3 of its properties. So this is what your trapezium should look like, or you could draw an isosceles trapezium. What are the properties of a trapezium? First one here says it has only one set of parallel sides. Yes, and that is the line above here and the line below in this case. The other opposite sides are not parallel, and that's how you identify a trapezium anyway. Only one set of opposite sides are parallel. The other opposite sides will not be parallel, as in this case, the one to the left here and the one to the right here. They are not parallel, and that's how you identify a trapezium. It has no line of symmetry, as we discussed in our last lesson, except of course if it's an isosceles triangle, which is isosceles trapezium, which is gotten from an isosceles triangle. So then the sides are not equal. As you can see here, a trapezium will not have equal sides. The angles will also not be equal if the sides are not equal. Now I believe you were able to write at least 3 of these. You did? Then I'm going to celebrate you with a chair. Now, moving on to today's lesson, let's begin with our expected outcomes. At the end of this lesson, you should be able to state the properties of a circle, and you must wonder, like I've said earlier, does a circle have any properties? I mean, no sides, no angles. Then what is there to study about a circle? We'll see about that in this lesson. You should also be able to identify, you should be able to name, you should be able to draw circle lines. Then finally, you should be able to differentiate between the diameter and the radius and state the relationship between them. Now you must say, oh, okay, it's the diameter and the radius. Well, let's see what we can learn about that today. So now, what is this shape? Of course, everyone knows it. You are crossing it at home. It is a circle. Now, this shape is a circle. The center of a circle is always the same distance from any point on his body. I'll take that again. From the center to any point on the body is always the same distance, whether from here to this place, or from the center to the left, or from the center to the top, or below. Let's see. This is a red line showing the distance from the center to the top. Now I want you to move. As it goes around, you can see that the red line does not come into the circle, doesn't go outside the circle, it remains on the body of the circle. I'll let it go again so you can see. On the body of the circle throughout. That means this is a circle. But it is not all round shapes that are circles. Let's see some shapes that are round but are not circles. This, my friend, is not a circle. And why is that? If I activate this line and it goes around, you see that the red line immediately falls outside the circle along the journey. In fact, on most part of the journey, it falls outside the circle, showing that the distance from the center to the left in this case is small, but from the distance from the center to the top is more. The distances are not equal. So this is not a circle. Let's see another one. This also is not a circle. If I activate the line, goes around, you see that it falls outside of the line most of the time. I mean, the distances are not the same. Now let's talk about the parts of a circle. Now, circle has lines, then it has shapes. Today we'll focus on the lines that form a circle. Now, remember lines? The song about lines? Lines all around you and me. Long or short or thick or thin they'll be. Curvy, wavy, broken, fancy, free. Look around, how many can you see? Now we'll look at the lines that form a circle today. Now, this is a circle. A line that goes round this circle on the body of the circle is called a circumference. Say circumference. Circumference. Good job, you. Now, note the spelling of circumference, because Auntie Fumi might just ask you to spell it one of these days. You know, I like to give you tips and tricks. All right, this is a circle. So let's see what the circumference is. This yellow line that goes round is what you call the circumference. But you may wonder, Uncle Baje, this is also a circle. Well, a circle is made up of two parts, just like your house is made up of two parts, the compound and the fence. So the fence is what we call the circumference. The fence of a circle is the circumference. Okay, so let's leave it at that. It's also called the perimeter sometimes, but most times we call it the circumference. Now, a circumference is a closed shape. There must be no space in between the lines. If there is a space, it's no longer a circumference. You know, it's just like you leave your gate open. The fence is covered, but the gate is open. I mean, your house is not protected, okay? So your house is not covered, so to speak. Now, so this is a circumference. But this is not a circumference because this man has left his gate open, okay? The gate is not closed. So we can't call it the circumference. It doesn't cover the house. Now, if it is not a complete circumference, we call it an arc. And this arc is spelled ARC. It is different from ARK, the Ark of Covenant or Noah's Ark that he traveled with his people in. This arc in mathematics is spelled ARC. An arc is just part of the circumference. The circumference is full. Okay, the circumference is full and closed, but the arc is not complete. This is an arc. Now, a line that I draw from the center of the circle, this blue point, to touch the circumference. Remember, we're using the yellow line to represent the circumference. A line that I draw from the center, a straight line that I draw from the center to touch the circumference is called the radius. I'll take that again. A straight line that I draw from the center to touch the circumference is called the radius. Now let's see the radius in this case. Say this yellow line comes from the center and touches the circumference. But it doesn't have to go from the center to the top. It can go from the center to any point. This is another radius. It goes northeast. This is another radius. It goes southeast. And this is another radius. As long as you draw a straight line from the center to any point on the circumference, you have a radius. Now, if I draw a straight line inside a circle and it touches the circle at 2 points, how many points? 2 points. We call that line the chord. And this chord is spelled C-H-O-R-D. C-H-O-R-D. It is not the same as the cord that you use to tie something or the umbilical cord. That one is C-O-R-D. The chord in mathematics is C-H-O-R-D. And it is a straight line that I draw inside a circle. It must touch the circumference at how many points? 2 points. This is the first point and this is the second point. So this is a chord, my friend. That line is what we call a chord. Let's see. This is a chord. This is also a chord. So it doesn't have to be a horizontal line or vertical line. It must just be a straight line and it must touch at 2 points. This is a chord. This is a chord. This is not a chord, okay? Because even though it's a straight line and touches at 2 points, it has extended beyond the circle, okay? So this is not a chord, okay? It must just touch. It must not cross. So this is not a chord. Okay, this is not a chord because it's a straight line inside the circle. Well, it touches only at 1 point. It doesn't get to the second point. You can't manage it. It's not a chord, okay? This is not a chord. It touches 2 points, right? 1, 2. But do you know what the problem is? It is not a straight line. So a chord has to be a straight line and it must touch the circle at 2 points. Now, I want to talk about a special chord. This is a chord starting from point A and touching point B. But it doesn't pass through the center. Now, if I allow it to pass through the center like this, yes, it is called, it's a chord, quite all right, but it's a special chord. We call it the diameter. Say it, the diameter. Okay, I'll take that again. It's a special chord because it's a chord. Any line that touches 2 points is a chord. But if that chord passes through the center of the circle, we call it a diameter. Okay, so now a diameter divides the circle into 2 equal parts. You know, just like when you want to share an orange with your brother, you divide into 2 equal parts along the center. That is a chord. It's a diameter. So this is a diameter. It divides the circle into 2 equal parts. This red part here is the same as this other red part on top. Now, a diameter is also the same as 2 radius or 2 radii. The plural of radius here is radii. Okay? That's the plural of radius, radii. So it's not radiuses. A diameter is 2 radii that form a straight line. We say they are collinear. They form a straight line. Look at it go. See, one radius goes this way, one radius goes this way. But at the end of the day, they form a straight line, and that's a diameter. We say 2 radius make 1 diameter. Say that with me. 2 radius make 1 diameter. Or 2 radii make 1 diameter, as the case may be. So, let's move on. Now, this is also a diameter, okay? As long as it touches 2 points and passes through the center, it is a diameter. This is also a diameter. As long as it passes through the center and touches 2 points, it divides the circle into 2 equal parts, and that is a diameter. Now, it is time for some activities. Let's identify these lines. The straight line AB is dash. The straight line AB, I will not point to it for you. The straight line that joins A and B together is called what? Did I hear you right? Let's see what the name is. It is called a chord. Why? Because it's a straight line and it touches 2 points on the circle. Let's take a look at another one. The line BC. Look at the line that connects BC together. What do we call that line? Is it a straight line? I don't think so. Well, we call it an arc. An arc is part of the circumference. So BC is just part of the whole circumference. So we call it an arc. Let's see another one. The line DX. The line DX is what? Look for the line that connects D and X together. That should be easy for you, my friend. It is called the radius because it comes from the center and touches the circumference. That's the radius. The straight line AC, because there are 2 lines joining AC. But the straight line AC is called what? Did I hear you right? Did you say diameter? It's a diameter, my friend, because it touches 2 points and passes through the center. That is a diameter. The line AX. The line AX is called what? That should be easy for you, my friend. The line AX is a straight line coming from the center and touching the circumference, and that makes it a radius. Now, finally this one. The closed shape ABCDA. From A, go to B, go to C, go to D, back to A. What do we call that closed shape? You know it already. It's a circumference. Good job, you, my friend. Now it's time for your homework. You are to capture the shape and name the lines that have been given. I have LN, MQ, PQ, OM, MP, LMQ, P, and L. I'll give you 30 seconds for that, and I'll be back for Magic Tuesday. Hello children, you're welcome to the Magic Tuesday segment where I show you all the shortcuts in mathematics. Today on the Magic Tuesday segment, we will learn a new method of multiplying numbers. It is the same Chinese method that I introduced to you last week. Now I have 4 more examples for you to see how it's done. Our first example for today says, multiply 424 by 63. Now using the Chinese method, the first thing you want to do is that you want to draw a rectangle quickly. Now you put the numbers on top and by the right of the rectangles like this. I always like to put the numbers with the larger number on top and the smaller number to the side. It makes it easy for me to draw the rectangles. Now what you need to do now is to put a line between each number. So between 4 and 2 you draw a line, between 2 and 4 you draw a line, between 6 and 3 you draw a horizontal line. Now what we want to do is that inside each box we will put the product of some numbers. In this box I will put the product of the number on top and the number to the side. The number on top is 4 and the number to the side is 6. So 24 must go here. And in this place the number on top is 2 and the number to the side is 3. So 2 times 3 must go here. But it must be in double digits, so I have to help myself by partitioning each box like this so that I will have 2 spaces in each box for each of the 2 digits. Now, the beauty of this method is that you can start from any box you like. I like to start from here to show you that it's possible. In this box, 4 times 3 is 12. And I put 12 here, 1 here, 2 here. Now let me pick this one. Here I will have 4 times 6, and that is 24. Now let me pick this one, just to show you that you can start with any one. 2 times 3 is 6. Now here I will have the number on top is 2, the number to the side is 6. 2 times 6 is 12. Now let me pick this one. 4 on top, 3 to the right. 4 times 3 is 12. And finally this one. 4 times 6 is 24. You can start from anywhere. Now the next thing to do is that we want to add numbers again diagonally, and that's why we have the diagonal lines to guide us. So you had this diagonal, you can start from anywhere. You can add any one first. Let's see how that goes. So 2 at the end of this one. 1 plus 4 plus 1 is 6. From here 2 2 0 2, everything gives us 6. 1 plus 4 is 5, 11, and then here 2 at the end of it. Now we're almost there. The next thing to do now is just to take this one that has double digits. I take the 1 to the next place and I add it up. I get 7. My final answer is 26712, 26,712. Very simple, right? Let's just take a look at another example to clear up any gray areas that you may have. The second example says multiply 609 by 58. So again, I begin by drawing a rectangle. I put the bigger number on top, 609, and on the side 58. Then I draw a line in between each number like this. And of course, since I'm going to be putting 2 digits in each box, I partition it diagonally. Now I can start multiplying from anywhere. I like to do this sum first. 0 times 5, because 0 is on top and 5 is to the side. That's 0. So I write 0 0 because I must put 2 digits. And here 0 times 8 of course is 0 0. Now here I'll put 6 times 5 because 6 is on top and 5 is to the side. So 6 times 5 is 30. Now here I'll put 6 times 8 because 6 on top, 8 to the side. 6 times 8 is 48. So this is just to show you that you can start from anywhere. And then here I put 9 times 5, which is 45, and finally 9 times 8, which is 72. Now of course we are going to add diagonally like this, like this, like this, like this, like this. So I'll just let the answers come up. Here I have 7 plus 5 is 12, 8 plus 0 0 plus 4 is 12, 4 plus 0 0 is 4, and then 3 at the end of this. Now I'm going to be carrying 1 from here to here and 1 from here to here. So let's see how it goes. So 12 plus 1 is 13, and then 1 goes to the next one. 1 plus 4 of course is 5. So my final answer is 35,352. 35,332, my friend. That is the Chinese method of multiplying. We also call it the Nigerian method, and it is very, very easy. Practice, my friend, and you will never lose your way. Till I come your way next time, remain wonderful mathematicians.